Hi, here's Maciej. Today I would like to talk about using a Remis tool to generate a tile map for ZX Spectrum for assembly language. But we will start with a few words of general information. So when it comes to sprites, the concept of the sprites is quite similar between assembly and basic. However, tiles are completely different. So if you learned how the tiles are working in a basic, you can be sure that there is a completely different concept when it comes to assembly language. And we are going to talk only about assembly language. Now, palette. Now we are going to palette. So now palette, where each color, there are two options actually from assembly language, where each color can have 8 bits or 9 bits. So you have to know which palette you are defining, and then you have to import it properly, whether each color takes a 8-bit or 9-bit. So there are two options. You just have to know which one you are going to use. When it comes to tile map, each tile carries also 1 byte of information or 2 bytes of information. And in this video, we are going to talk about tile map, where each tile has only 1 byte. I'm going to make another video in which I will explain you how to define a tiles where each tile takes 2 bytes. Well, the difference is that if one tile has only 1 byte of information, this is just basically the offset to. So when just let me clean that. Go away. Okay. This is only the index. Now, and this is the tile number 1. And I can start painting this one, and you can see down here shows me that I'm painting here tile number 1. So tile map is basically an array of bytes where each element is this array is an offset to a tile. In the case where tile map carries only 1 byte per tile. But first, let's start with the sprite editor. We are going to use sprite editor to generate tiles, and then we will place those tiles on the tile map. In order to generate tiles, we have to toggle 8 on 8 and 4-bit mode. So sprites are usually 16 by 16 pixels, right? Tiles, however, are 8 by 8 pixels. So what we're technically doing, we are taking the whole sprite and we are dividing it into 4 smaller structures. Now, each pixel carries color information. In case of sprites, each pixel can carry it's a 1 byte, so it can reference all 256 colors. But in case of the tiles, each pixel has only 4 bits of a color information, which means we can address only 16 colors. I will just explain it with a small drawing. Let's imagine that this is a tile, and now it has 2 pixels, green and red. Now, if we will use 8-bit color palette and store this tile into a file, that would create 2 bytes, right? One with the palette offset for the green and 1 byte with the palette offset for the red color. That wouldn't work in assembly anyway, but this is the way how it would store 8-bit color information. This is working for sprites, but not for tiles. Now, when it comes to tiles, there is only 4-bit information about a color, and what is happening, we have a byte, 1, 2, 3, 4, 5, 6, 8. And now, if we want to store those 2 pixels into a file, they will go into one single byte, where green will occupy 4 bits, and the red will occupy also 4 bits. This way or other way around, I don't remember, doesn't matter. Hey, so here we have our tiles and the color palette. Now we know that we can only reference 16 colors, but I can still choose here, for example, color number 216, and that's not where we are going. That is not what we need right now. What we need right now, we don't see this palette offset. This will be relevant for another video where we are going to talk about tiles which have 2 bytes of information. Now our tiles have only 1 byte of information, which means that we can only use 16 colors for the whole screen, for the whole tile map. Therefore, we are going to palette and we are going to remove all those colors so they are not tempting to use, that we can use them. And now I would like to have the first color as a transparent. This is 1C7, I always forget it. Because it's a good idea actually to have transparent color in your color palette. So now what I did, I just removed all the lines, but the first, which gives us the 16 colors. We start from the beginning. I leave the first tile empty and start from the second tile and just draw something. Everyone knows what comes next. 1, I don't know, 3, doesn't matter. Okay, very nice. As we put a lot of effort into this sprite sheet, I'm going to download it and call it, I don't know, AAA. Now let's have a look on it. Oh, there is already AAA, so we'll get rid of it. Just download it once again. And it has 16 bytes. Now, you can't import that large tile map into assembly language because let's have a look on the memory map. Now, the tiles map goes at third memory slot. This is the 5th 16 kilobyte bank, and if we would start loading from here 16 kilobytes, then we would end up somewhere here at 8000. It's where the program memory starts, so this next will simply crash. So the file that has been exported is obviously too large. We have to cut it. Now we have to calculate the size of the size that we want to leave. We have 2 tiles, each one is let's say 16 by 16. 16 by 16 is 256, but we have 2 tiles, so however only 4-bit information, so divided by 2, which gives us 256 bytes. So those 2 tiles are taking 256 bytes. So let's start some hex editor and remove things that we don't need. Don't know how to jump down because I'm not used to this keyboard. And there is no key here. Okay, but it removes. And now 256 bytes. This looks much better. That's our first file. Now let's go to tile map. Finally we can find something. We clear it. Now it asks me which tile I would like to use to fill up the map, because it has to, each position has to reference some tile. And now I left the first tile empty, so we will use 0, which will fill up the whole map with a tile 0, which is transparent, so it looks empty. Now let's start painting something that makes totally sense, like A, B, and 3. Nice. And as you can see, if I move the cursor over EA, it shows me that this is the tile offset number 1, and here number 2, and this is number 4. And the size 40 by 32 is because if I multiply if I multiply 40 by 8, it will give me 300. What? 40 by 8, 320. That's the resolution of the spectrum screen, of the next screen. So this tile map will fill up the whole screen. Let's download it and we'll call it AAA. And we can leave it at that, so it doesn't have to be cut or something. Now we have to transfer these things somehow to our ZX Spectrum Next. For that we are going to use this ZX Spectrum Next assembly guide. Very good book, and if you go into the internet, you also find that there is a GitHub repo with examples, samples, and there's a tile map. And this is exactly one that we are going to use. I have already imported it. That's the tool. I have already imported it into my Visual Studio Code, but you can see there is no modification on May ISM. Let's copy AAA into there. There is already AA, but we are just replacing it. Okay, this is the original file that comes with the book. I'm not going to discard it because there is a lot of comments here and there's a book about it, so you can read by yourself. We are just going to adjust it so that it works in my case. So what I have to do is just to remove... Oh, we forgot to export the color palette, but this example has color palette of 16 colors, so we are fine with it. And there is nothing special about color palette, so I just know that I have to remove this one and AAA, and SPR file is also. Color palette stays the original one that is somewhere here in this example. And this has to be called project next. Now I'm going to compile it. I have a small script that compiles this program and copies it over the SD card because I'm running it on the Realnex hardware. What does it want? Error 0, it actually worked. Okay, good. It's on the SD card. Now, let me see what you can see, because this is my next running right here. What I'm doing, I'm inserting the card and pressing the reset button. It quickly reboots. And now in the menu, I have the project that we are working on it right now as X. So when I start it, we see our tiles exactly as they should be. No. Hold on a second. A, B. No, they are kind of shifted. Why are they shifted?
Why are they shifted?
I know why they are shifted. Crap, Iris, include header over here. You have to remove include header. Let's go once again. Download the map. AAA. Okay. Copy header. It's in the download. Okay, this is this one. Now, gives me one more chance. Give me one more chance to do it right. Replace, compile, and so the header is for the basic. You definitely don't want to have a header. And they are not shifted anymore. Very nice. So now we have learned that we have to untick the header in case of assembly language, but it works. Now in the second video, I'm going to show you the tiles that can use a full color palette of 256 colors. Ta-da!